Hello, everybody. This is Jagdish Mirani from Pivotal Product Marketing. Welcome today to our webinar entitled Session State Caching with Spring. Session state caching is one of the top use cases for Apache Geode and for caching in general, so we're pleased to bring you the topic. With us today is John Blum, a member of the Spring Data team and project lead for Spring Data GemFire, Spring Data for Apache Geode, and Spring Data for Apache Cassandra. John joined VMware in 2011 prior to the Pivotal spinoff and worked on distributed systems, in-memory data grid technology that is now Pivotal GemFire. He officially joined the Spring team 3 years ago in August of 2015 and has been working across the Spring Data portfolio. An interesting little tidbit about John that I just found out is that he started programming very early on a Commodore 64. So it's been a long time, John, and been a lot of changes. So at the moment, he's completely entrenched as our SME for Spring Data. So with that, John, take it away.
Thank you, Jag. All right. Yeah, that made me feel a little bit older. Going back to my Commodore days, I got my first Commodore in 1983, actually. So I've been at this for a while.
Yeah.
Let me first start with this screen share here. Can everybody hear me okay?
Yes.
All right. Excellent. Share. All right. So hopefully we won't have any blips this time. Let me jump over to my slides. All right. So, yes, my name is John Blum. I'm on the Spring team, specifically working on the Spring Data portfolio. I'm also the lead for Spring Session for Apache Geode and Pivotal GemFire. So, and that's the topic of our discussion today. And I'm excited to present to everybody on this particular important topic. All right. So maybe some of you were actually in our webinar in January, where we actually began this story on caching in general, and with Apache Geode and Pivotal GemFire in particular, and how Spring kind of ties those together with your application. So this is kind of a continuation of the same story, and this time we're going to focus in a little bit more on the web tier of our application architecture. So if you were with me last time, you probably remember this diagram here, or this illustration. Probably not unfamiliar to most people. You know, you have your traditional in-tier architecture here. You got end users who are either accessing your application, if your application is a web application, through a browser, maybe a mobile device, smart device of some sort. You have web servers, you have application servers running your applications, business logic, and so on, and you got some back-end data store. And the gist of this diagram was that essentially at the time, well, the particular problem we were addressing then was that your database was becoming the bottleneck. It wouldn't be able to scale up to meet your demand. And as an effect, that would have a rippling effect across your application architecture and put additional strain on your application servers and your web servers. However, the same thing can sort of happen from the front end, especially when you consider all the multitude of different users that are using your applications, which may not necessarily be people. They could be other applications or other devices. And so now we have a kind of a proliferation of this problem coming from the front end. And essentially this sets your whole application architecture on fire from multiple different angles. So how does Spring help in this? Well, we also went on to basically revisit this architecture and then apply Spring to it at each tier in the application architecture. And in this particular case, we're basing it on Spring Session. So in your web application tier, what we want to do is we want to be able to manage session state. And why is session state important? Well, session state helps us remember what the user is doing with their web application. It keeps track of what the user is doing. We can have this more conversational style interaction with them, because HTTP by its very nature is stateless. Therefore, whenever you submit a request, it's a new connection, and it closes that connection when the response is given. So we need to have some way of basically keeping track, identifying who the user is and what they're currently doing, and the session's one way of doing that. And of course, as you can imagine, this puts additional strain on our application servers or our web servers if we have dedicated web servers, particularly with memory, for instance. So Spring Session is a technology that can help you integrate with different technologies that can alleviate some of the strain on your servers, particularly as it pertains to memory, for instance. We talked about the application server tier last time, where you could use the Spring Framework's cache abstraction combined with an underlying caching provider like either Apache Geode or Pivotal GemFire. There's actually many different providers, but in this particular case, we are backing that up with Apache Geode or Pivotal GemFire. And of course, you can also do caching in your database tier. However, we're not going to be talking about the application server or the database today. We're going to be talking specifically about the web tier and Spring Session. So let's drill into what Spring Session is a little bit. First and foremost, Spring Session is actually a framework, more like a service provider API for different providers to be able to plug in different implementations of being able to manage your session. And Spring Session actually includes quite a few different modules for different types of stores, depending on your application architecture, whether you're using Apache Geode or Pivotal GemFire, or maybe something else like Redis or Hazelcast, JDBC, Mongo. It actually has pretty extensive support for a lot of different providers. In this particular case, we're actually basing it on Apache Geode and Pivotal GemFire. So indirectly, to access those two stores, Spring Session actually delegates to Spring Data GemFire or Spring Data Geode if you're using the open source Apache Geode version under the hood. And of course, Spring Session and Spring Data Geode, more so Spring Data Geode, is actually based on the core Spring framework. So you have all this tremendous power under the hood at your disposal should your use case expand. And then to tie it all together, of course, you got Spring Boot over here to the left, and that makes basically everything simple, especially configuration. And as you know, Spring Boot provides support for Tomcat, Jetty, and Undertow out of the box. So you can get started with any one of those particular containers. And you might do so for different reasons. For instance, Undertow helps support non-blocking use cases if you're into the reactive world. And of course, Tomcat actually has async support as well as Jetty. So you have a lot of different options there and flexibility in how you want to configure things. And Spring makes it really simple to do. So let's drill in a little bit further and talk about Spring Session in particular. So Spring Session by default actually will replace, if you have a web application and you're dealing with HTTP protocol, obviously integrates with the JavaX servlet framework. And because the HTTP servlet request and the HTTP session are interfaces, they're really easy to provide an implementation for those things. And we can actually change up what the backing implementation is for HTTP session. So it replaces the HTTP session in the app container with one that Spring Session explicitly provides. We actually adapt the HTTP session, and we have specific provider implementations depending on what store you plug in, right? Like if you plug in Apache Geode or Pivotal GemFire, there's a store-specific implementation of the HTTP session for those stores so that it works seamlessly with those stores. Spring Session also provides the ability to support RESTful APIs. Now, if you're not dealing with a web browser, you may not have the ability to deal with cookies. You have no idea what your clients are. There might be other applications, other devices. Therefore, Spring Session supports putting that session ID in header so that you can support session state and RESTful APIs as well. In addition, WebSockets. You have this continuous connection between your client and your server application, maybe you're streaming events, what have you. Then Spring Session supports keeping the HTTP session live even when you're sending WebSocket messages back and forth, right? There's no notion of, well, I've refreshed the session because I've sent a new request, therefore, it could time out. So Spring Session handles that particular case. Replaces WebFlux's web session in the app container in neutral way. So this is kind of touching on the Spring's WebFlux support for reactive web applications. So We have support in Spring Session to replace the web session. So Spring Session is giving you quite a bit of power out of the box in an app container neutral way. So you're not ever tied to your app container. Now, as you know, Tomcat actually supports clustering of sessions too, but then you have a very specific configuration that's tied to Tomcat. And at that particular point, if you were to change application containers to say Jetty or maybe like something like JBoss, then you of course have to reconfigure your server to manage your session state in a clustered manner with those particular containers. Spring Session gives you a more app container neutral way to do that. However, Spring Session isn't an island. It needs a provider implementation. So the two particular technologies we're talking about today are Apache Geode and Pivotal GemFire. What are the difference between these two? Really very little. Apache Geode is just the open source version of Pivotal GemFire, where Pivotal GemFire is the commercial offering offered by Pivotal with additional services. So in effect, these two technologies are really similar. They're both in-memory data grids. I'm going to actually explore that term a little bit more in just a minute here. But effectively, these are distributed systems that give you great power when it comes to use cases like caching, specifically session state caching. So let's drill into what an in-memory data grid is a little bit more. Two key pieces of this architecture is that one is that your data is stored in memory. Obviously, it's much quicker than actually persisting data to the disk, unlike a database, right? So a database writes to the disk. There's a great deal of latency there. There's both the option of storing that data on the heap, in the JVM heap, as well as off heap. So to reduce the memory pressure on the JVM, obviously stop the world GCs or out-of-memory errors aren't a good thing. You also additionally have the option to store this data in off-heap memory. There's also the option to overflow data to disk as well as persist to disk. So this can be a persistent store as well, and we're going to talk about that a little bit later in this presentation. However, one of the other key aspects of this architecture is that it's clustered. Obviously, not all your data is going to fit in memory, especially on a single node. So there's a collection of nodes that all work together to basically store your data. And it does so in a very intelligent way. It partitions that data. It can actually replicate that data in a redundant fashion for high availability. And of course, you know, as I already mentioned, it can be persistent as well. However, that's not all. You can also handle multi-site configuration. So this is another added advantage of using a specific type of provider like Apache Geode or Pivotal GemFire under the hood, is that you can actually replicate across different data centers. So you can have high availability in a lot of different fashions. So the two most common patterns in multi-site are active-active. So maybe you're handling geographically disparate groups of people on either ends of the globe. Maybe you have your European and your American contingents that or clientele. Or you could have an active-passive architecture where you have one cluster in standby in case one goes down. So there's all kinds of different configurations that you can do. It's a highly configurable system and packs a lot more punch than just caching. However, I think we've reached a point now where we've probably laid the foundation enough. What I want to do today is just show you a couple small examples that I've already cooked up largely, so they're mostly written. There won't be any real live coding today, which is fine. I just want to show you basically how you can get started very simply using Spring Session. So jump over to my IDE here. I have two things. I have a web application client, and I also have a server. Now, what does that mean exactly? So both of these are Spring Boot applications, first and foremost. One of them is a cache server application. So this would be the server side of Apache Geode or Pivotal GemFire. And what I'm doing here is I'm using Spring Boot and Spring Data GemFire and Spring Session to actually configure and bootstrap my GemFire server. There's different ways you can do that, but if I'm inside my IDE, the quickest way to do that is just to use Spring. Of course, GemFire and Geode provide tools like GemFire Shell or Geode Shell to basically start up and configure servers as well. However, that could be a little bit more cumbersome and tedious if you're not familiar with these two products and you come from a Spring background. So it's actually quite simple to set this up using Spring. So I just have this Spring Boot GemFire server class, which is a Spring Boot application. This is a Spring Data GemFire annotation that says, I want to make this application a cache server application. So it actually creates a server-side cache, a pure cache, and that's different from my client cache because in a pure cache, I can have other members that connect in that cluster, right? So I want to be able to have a distributed system, maybe 100 different nodes, 1,000 different nodes. I want to form a cluster of nodes that basically serve my application's use cases. So they all work together as a pure distributed system. And a pure cache functions quite a bit differently than the client cache because it has different guarantees that it enforces, like consistency and high availability and stuff like that. Whereas a client connects to and talks to your server to basically perform data access operations, receive events, that sort of thing. So very different expectations there. Anyway, this is all you need to make it a cache server application, a pure node in a distributed system. Right now, we just have a single node. I have this enable locator option, which basically just tells other peers how to find each other. And then I also have a management component. So this allows me to connect up with GemFire shell. So we're going to jump into GemFire shell in a minute and just take a look in terms of what's going on in the cluster. And then I just have the single Spring session annotation to basically enable all this stuff, to basically enable GemFire and Geode to manage the HTTP session state. And I have this on the server side because under the hood, what GemFire and Geode needs to be able to persist that information is a data structure to store the session state. And the most common, well, the primary data structure in Apache Geode or Pivotal GemFire is a key value store or a map, very equivalent to the Java util map, right? So if you're familiar with something like Hazelcast, same thing there, grid gain, same thing there. You know, you have this mapping of key to values. And the key in this case would be the session ID. The value, of course, would be the session. And this enable GemFire HTTP session works client-side and server-side. So on the server, it's actually going to create the server-side region and to configure the expiration policies. It has several different attributes on the annotation itself that you can affect, like you can affect the type of server region that you create. And by default, it gives you a partition region, so it shards that data across all the nodes in the cluster. There's also replicate regions on their data management policy types that you can configure on the server. So GemFire, again, and Geode are very flexible in what you can do. Some of these annotations actually pertain to this client side, like the pool name, the client region shortcut, so I can also affect the type of region I'm creating on the client side. So the region name has to match both on the client and the server. And that's how GemFire knows to basically send data from a client for a particular data store to the server side for a particular data store or data structure, in this case, the region. And you can actually configure the region name, but there's a default just called clustered Spring session, so we'll see that in a minute. Anyway, there's quite a few different attributes here. You can tweak the configuration, but out of the box, you really don't need to do anything. It just uses the default, inactive interval. So this is your expiration here of 30 minutes. And of course, I think for this particular case, I've actually changed that. So I've got 30 seconds. And that's just a demo of this application and show you kind of the effects of what's happening there. Other than that, that's all I need. I don't need any more configuration. I got a few annotations here that give me a lot of power. In fact, neither one of these were required, but that just is going to give me the ability to, if I wanted to, add additional peers and specifically connect to the server via GemFire shell or Geode shell in this particular case. So on the client side, not much different. It's also a Spring Boot application. Instead of a cache server application, it's a client cache. So that's all I need to make it a client that will connect to the server. And under the hood, there's actually a pool that gets configured to talk directly to the server. You can actually have this pool configured to talk to the locator. And it's more advantageous to talk to locator, especially when your cluster consists of more than one node, because you can take advantage of other features in GemFire and Geode like load balancing, single hop data access, tons of other advantages to using a locator. However, by default, this application is just going to connect directly to that cache server. And then, of course, I've also used the enable GemFire HTTP session annotation on the client side as well, so that it will set up the region. And the region by default is a proxy. All it does is it just basically forwards all requests to the server. There is an option to make it a caching proxy, so you could actually store the data locally as well, which is actually an advantage. So that's what's considered to be a near cache, is that I can have data locally. And GemFire and Geode will take care of keeping that data in sync for you across the wire. Like, you don't have to worry about whether your HTTP session state on the client's different from your session state on the server, especially if you have multiple clients and they're accessing your application, a single user's access from multiple sessions, right? Like, GemFire, one of the strong suits of GemFire is consistency. And I've actually enabled subscriptions here so that I receive events about changes in state to that HTTP session. And we're specifically interested in the case where, the session expires there. Other than that, I just have a few other endpoints here. I've got a hello endpoint just to let me know the application's working. And I got a more interesting endpoint for attributes. So that's just the Spring MVC configuration. And then the rest of the stuff is really just helper methods to basically serve those two endpoints. And that's it. That's all that this application is. And this is the only thing we need to basically enable Spring Session, along with putting basically Spring Session on the class path. So I have Spring Session data Geode. So we're using Geode in this particular case. I could use GemFire, and that's as simple as just changing my dependency from Geode to GemFire, and that's it. We're done. That's all we'd have to do. And then we're using GemFire. We get all the GemFire dependencies and so on. So let's run this thing. This one is not particularly interesting, so I have one more demo that I'll show. It's a little bit more interesting. Not much, a little more. So I've already got my tabs open. So I'm starting up the server. You see that it's Spring Boot 2.0.1 release, the latest Spring Boot release. I've actually got the logging turned up so you can kind of see what's happening when this example is run. You'll see a bunch of stuff you'll see a little bit from Spring initially here, initializing the container. And then you'll see a bunch of stuff from Apache Geode, the server that is. So you'll see it starting up the location services, the distribution locator. You'll see that it'll actually eventually create our region. So right here. So there's our region, and that's the default name for the region that stores the session state information, the key value store. And then it starts the cache servers for clients. And the default port in GemFire and Geode is always 4044. And then our server's running. So, sorry if that's a little small, hard to read. And now we can start up our client. Also using Spring Boot 2.0.1. And there's a bunch of stuff that the client starts up as well. But you can see that the Spring framework is creating my mapping endpoints in Spring Web MVC. And that's most of the output actually is all kind of Spring related on the client side. All right, now I can jump over to my web browser. Okay. So if I just hit that, I can just verify that it's up and the application's up. So it tells me I should go to attributes and more interesting things will happen. Essentially, all this application is doing right now is it's keeping a request count. So I can actually add attributes too if I want. I'm going to save that for the other demo. But essentially, if I just refresh this, as long as my session is active, that request count will actually go up because it's accessing the same session. So this is just a session attribute where I'm incrementing the request count so that I know that this session is active. So if we go over to GFish now, I can actually connect up. And because it's listening on the default locator port and manager port, it'll just connect right up to the manager as well. And that's because I've enabled the manager on my server. I can list the server, I can list the members. You can see my Spring Boot GemFire server there is there. And I also have my region, list regions. There's my clustered Spring Sessions region. I can actually describe that. Let's go over here quickly. And oops, sorry. Just want to make sure my session doesn't, it already reset. So now I've already got two sessions. So it's only 30 seconds, unfortunately. I wanted to capture it before we actually, shoot. Jump it back to that one. I wanted to, I know why. Let's grab that, put this over here. All right. So refresh it a few more times. Okay, now I got a request count of 3. So my session timeout set to 30 seconds right now, and that's real quick. So describe region. Let me pull this window up a little bit here. Okay, so you see that we have 2 sessions currently, and I can actually query that. There we go. So this is an OQL statement, very similar to SQL. So GemFire Geode supports querying. So you can start, I'm already starting to allude to some of the other benefits that you get when you actually use a provider like GemFire and Geode, is that you get all these other capabilities as well. So I can use this shell tool and I can actually go in. And right now what I did is I just queried the clustered session regions. I queried the key set. So I'm getting back all the session IDs right here. And the other session expired, but it leaves around a tombstone. So one of the reasons for that is kind of beyond the scope of this particular webinar, but one of the reasons for that is consistency reasons. It's probably longer than 30 seconds now, so if I refresh this again, my request counts back to 1, and if I do another query, then you'll see that there's now 3 sessions there. And then this one will be incremented a bunch of times. It supports actually adding attributes, but I'm not going to run that in this particular demo. Let's go to the other demo. So this is actually, this particular demo actually is in my GitHub repository, and there will be a reference to this example at the end of this talk, in my slides. And also, there is another sample that you can play with, which is part of the Spring Session project itself. So this is actually the source code for Spring Session Data Geode. And it has a very similar application, slightly more involved, so that it showcases how to adjust the configuration a little bit more, like say your port numbers on your cache server port and so on. But essentially it's the same thing, same as the web application. Actually, the example that I just showed you was based on this one that came from the Spring Session samples. So there's a lot of similarities between these two. Only difference is that this one actually provides a web UI. So let's run it. I just upgraded this to the latest version of boot this morning. Should be no problems. I have logging turned down so you won't see as much output. And we'll start the client. Both of these applications are very similar to, like I said, the last one. On the client side, again, we're using that client cache application annotation, which comes from Spring Data GemFire, and we're enabling Spring Session. On the server side, same thing. Spring Boot application that we're enabling the cache server application, and we're also using Spring Session. We've also made it a manager so that we can connect to it as well. I think this one has a, let's see. Yes. So here's the UI here. It, again, keeps the request count, but I can actually have some attributes. I can add value A or just A. So I can keep adding attributes to this one, to B, and if I just keep refreshing this, my request count goes up and my attributes remain. However, when the session expires, and right now that's set to 20 seconds, then essentially all this stuff resets as you would expect because the session's expired and everything goes back to square one. And this is all being managed by Apache Geode under the hood. There's no ties to the container whatsoever, other than when the container sends its version of the HTTP request, that actually gets handled by Spring Session, and that's what we're going to take a look at now. So there's the demo. If I wait for just 20 more seconds, maybe we can jump back to this. We can see that this guy's going to time out as well. Let's go to this slide. Jump back, let's see, 20 seconds gone by, continue. Yep, there we go. Actually, I already had my this in the field, so I think it actually already captured that. But essentially, it reset this session, and we are back to a request count of 2. Okay, so these demos are pretty simple, and you can actually follow along with this demo in the samples itself. You go over here. I'm going to grab a window real quick. Sorry, I'm jumping around. I got too many tabs open, windows open. Okay, pull you out. And put you back over here. All right, so hopefully everybody can see my browser window right now. Listen to desktop. I'm already there, yeah. Okay. All right, so hopefully everybody can see this guy. This is actually the sample I just talked about from Spring Session itself proper. There is the request count one. So it's actually all documented. So if you just go into the documentation for Spring Session Data Geode, you go to samples, you'll actually see this particular, so here's the starting point of the documentation. You go to samples and guides. You can go to the source code here, and you can go to the documentation for the sample that talks about everything, and it kind of breaks it down a little bit more detail as to what's happening. So you can follow along with that in the guide. Okay, so under the hood, what is Spring Session actually doing? Well, when the client sends the HTTP request, Spring Session intercepts that request by injecting a filter, a JavaX HTTP servlet filter, actually. And that's called Session Repository Filter. And what it does is it intercepts that HTTP servlet request and wraps it with a Session Repository Request wrapper. That wrapper delegates to another interface in Spring Session called the Session Repository. And it's this interface that allows me to basically access session state from multiple different providers. So Spring Session Data Geode or GemFire actually provides an implementation of the Session Repository interface that uses Spring Data GemFire and talks to Apache Geode, or alternatively Pivotal GemFire. And actually what the session implementation is a GemFire session, and I'll explain why more about that in just a minute when we get to some of the other advantages of using Spring Session with different providers. But the Session Repository interface provides a simple set of CRUD operations that you can use to access the session, like creating the session, expiring the session, or deleting the session, and finding it. And there's different methods to do that. There's obviously your method to find by a session ID, but you can also find by other attributes, particularly like session attributes that you may have indexed. So indexing is another important capability that Spring Session gives you, because you can handle all that with your particular provider, whether that's JDBC, Hazelcast, or Geode or GemFire. You can actually add indexes. And of course, you can take that a step further, and you can actually write other queries if you're using the Spring Data abstraction to perform other types of data access operations as well. Anyway, so it returns that GemFire session, and it wraps it in an HTTP session wrapper, which is a Spring Session class, which is a subclass of HTTP session adapter to provide some additional capabilities. But that adapter is itself an HTTP session, and that gets returned to the servlet container. Therefore, your application really only ever needs to actually interface with Spring Session using the JavaX servlet classes. You really never have a specific need to access the session interface directly or the session repository. You can do everything in your web application using the HTTP servlet request and HTTP session objects. But under the hood, Spring Session is taking care of all that plumbing for you and making sure that it's integrating with your provider. And of course, if you're using Spring Boot, it makes it even easier to do. So there's three different ways you can configure three different ways you can configure Spring Session. You can obviously, register this filter in WebXML, and this is a snippet of code that you would need to do that. And that's all explained in the documentation, so I'm not going to talk about this specifically. And your preference hopefully won't be to do that anyway. Another way to do it, of course, is to actually create an initializer class. So if you're not using XML and you're using Java config, Spring Session provides this abstract HTTP session application initializer, which actually uses a Servlet 3.0 API to register that filter programmatically. And all you have to plug in is your config class, and this config class would be your provider implementation configuration. In GemFire and Geode's case, right, what we had to do is we had to create an instance of a cache, we had to configure a pool, we had to set up a region so that we could actually store the HTTP session state. And a lot of that was handled by the annotations, the client cache application annotation and the cache server application on the server side. So it made it a lot simple to do, but that's where that configuration would come from. That's where those annotations would be specified as in that config class. And this is the Java way to do it. However, if you're like me and you don't want to do a lot of extra work like XML or Java config, you can just use Spring Boot. And Spring Boot will actually take care of registering the filter for you and wiring in your provider based on what's on your class path. And that's it. All you have to do is specify the annotation to enable Spring Session in that particular case. Down the road, I actually have another project that we're not talking about today, which is called Spring Boot for Data, GemFire, and Geode. And my intent there is if GemFire or Geode are on the class path, specifically Spring Data, GemFire, Spring Data, Geode, or Spring Session, it'll just actually enable session state caching for you. So that'll be another added benefit. You won't even need to enable GemFire HTTP session annotation anymore to enable Spring Session. So what does the API consist of? Well, in the Java servlet world, we already talked about that HTTP servlet request and HTTP session are your go-to objects to work with in your application. So nothing should really change if you're already working with these types. In Spring Session world, we don't encourage it, but there's the session interface and the session repository for working directly with your provider. Now, I've already alluded to some of the other benefits. Obviously, querying is a big plus. You know, if you're using Spring Sessions repository abstraction for your provider, you have a limited capability of querying, but if you want to go deeper, you can obviously tie in directly with Spring Data and start taking advantage of the repository abstraction there and really leveraging your provider under the hood. You can create indexes. I already mentioned there's actually an extension to the session repository interface called fixed, what is it called? Fixed attribute or something to do with binding by particular session attributes. So there's actually one more extension to the session repository interface. The name eludes me at the moment. But essentially, it allows you to search by any session attribute. And with GemFire and Geode, you can actually add indexes on those session attributes and make it quick to search by those particular attributes. You know, imagine if you had, like, say, an account that had a customer on it and you're trying to look up that customer by name. You can obviously add a index in GemFire and Geode to make that query really quick. Deltas. So Spring Session, depending on the provider, will support deltas, and deltas are supported with Apache Geode and Pivotal GemFire. There's different serialization mechanisms that you can use with Apache Geode and Pivotal GemFire. And the benefit there being is that if you use the serialization format that is provided by Apache Geode or Pivotal GemFire out of the box, that allows you to actually interoperate with native clients even. So GemFire and Geode can actually serialize your Java types in such a way that native clients can still access that data on the servers. It's useful if you have a mixture of different clients in your topology. You can also customize expiration. GemFire and Geode are very flexible when it comes to expiration. You have idle timeout expiration policies. You have time to live expiration policies. In a subsequent version of Spring Session, I'm also thinking about considering a fixed timeout expiration policy, which means that the session will time out no matter what after an hour. And that's useful in certain use cases, especially for customers who have a requirement to basically log the session out, log the user out of their session after, like, say, 60 minutes due to security reasons. So I'm considering different features like that. Anyway, this list is actually much more extensive than this. If you go into the documentation, you can see all the other added benefits, as well as looking at the core Spring Sessions documentation. But anyway, the point of this slide is really just to highlight the fact that essentially the only types you really ever have to worry about in your web application is just the types you've been used to all along, which come from the Java Servlet API. So I've been kind of loosely talking about this already, which means that, you know, while today is focused on caching, GemFire and Geode combined with Spring gives you a lot more power than just caching. Obviously, you can get into more system of record use cases with CRUD and querying, simple querying operations using OQL statements, very similar to SQL, as I already mentioned. You can use continuous queries, which is a form of event streaming and processing in Apache Geode and GemFire. So this is akin to in other stores like registering interest, like I'm interested in particular data values or keys. With GemFire and Geode, they have a continuous querying mechanism, so you can specify your interest based on a query using a predicate, which is really powerful, right? Like maybe you're interested in temperature readings above and below a certain threshold, and when the temperature rises either above that threshold or below it, you get an event to your client. So you can use it for stream processing. It also has function executions. So functions are very similar to database stored procedures and functions. However, the difference there being is that it's a distributed compute. So you take your function to where the data lives and not bring your data back to your compute. So you can have sort of this map-reduced style of function execution. And you can write your functions in Java. And using Spring Data GemFire makes it really easy to do. You can use POJO-based function implementations as well as executions. WAN site-to-site replication, I've already talked about that. Of course, GemFire and Geode is a clustered solution, but it's also a multi-site solution. So to make this even simpler, and this might be actually a subject for the next webinar, so we know that we can use, in our application architecture, we can use Spring, we can tie that together with Apache Geode and Pivotal GemFire, and Spring Boot makes it real simple to, start taking advantage of Spring Session and Apache Geode and Pivotal GemFire. But you still have to worry about managing your cluster a little bit. You still have to worry about scaling up your cluster, right? Manually adding nodes to your cluster. It is a scalable architecture. It's real simple to add nodes, right? We talked about the locator, which is used to find other peers. I can just start adding other servers to my cluster. However, if you wanted a more automated solution for all that, and you didn't want to have to worry about managing your cluster, especially when the load spikes, perhaps, then Pivotal Cloud Foundry is your option. And that's the only sales pitch I'll give you in this whole talk, but it really does make actually working with Apache Geode and Pivotal GemFire much simpler. In fact, under the hood, the Pivotal Cloud Cache service, which also provides session state caching, is using Pivotal GemFire under the hood. So that'll handle all your scale out, your resiliency, high availability. It just makes it real simple to set up and get going. And there'll be a lot of additional work that I'm doing in the Spring Boot Data GemFire Geode module to support PCC, or Pivotal Cloud Cache. And with that, those are my references, and I think they're posted in the session, the Bright Talk session, for everybody's references. Essentially, there's just a project page for Spring Session Data Geode. It's on GitHub. If you just Google that, you'll find it, and then from there, there's actually a link on the README for the documentation. I encourage you to go take a look at Spring Session and all the other capabilities it offers, especially the reactive support. That stuff's pretty cool. You can ask questions on Stack Overflow. You can read more about Pivotal Cloud Foundry's cloud caching service, as well as session state caching online as well. Just go to pivotal.io and check out the Cloud Foundry support. You see my examples online. I am JX Blum on GitHub. And the two demos that I gave you, one was a sample from the Spring Session Data GemFire project. The other one is listed here. And then I talked briefly about Tomcat's clustering solution and how that's a little bit different than Spring Session, so check it out. You can also reach me on Twitter. And thank you for your attention. So I'll open it up to questions now.
That's great, John. Thank you very much. As usual, you took it all the way from concepts to code. I think that's wonderful. So all of the references that John just went over are also in your attachments and links panel, so you can easily access it from there. There's also a questions panel. We've got a few questions in, so you can still enter your questions. Also, John's been really busy lately with doing outbound webinars and activities at conferences. He's sort of a regular at our conferences. So you'll get a lot of John's material on Spring Data by just entering his name in pivotal.io in a search window. So there's a tremendous amount of content that John has generated in the recent past that you can access that way. Okay, with that, let's go to our questions. So, John, you touched upon how easy it is to switch from Geode to GemFire, but suppose it's a completely different caching provider. How do I switch from other Spring Session providers, say it's Redis or Hazelcast, to using Apache Geode or GemFire?
Great question. Let's go back to the IDE. Now, let's go back here because this one's a little less busy. If I were using something like Redis, now each of the different providers have a little bit different capabilities when it comes to the client server side of it. One of the things that I really try to do in Spring Session, Data GemFire, and Geode is two things. One is make it really easy to configure both the client and server side. Now, of course, you always have the option to configure your servers however you want, whether you're using GemFire shell to do that or GFish, Geode shell. as well as using cache XML, like GemFire and Geode's own configuration format, to using the API, whatever you want. You can configure your servers however you want. But one of my goals was to basically make this enable GemFire HTTP session work seamlessly on both the client and the server. And the other goal was to basically make GemFire and Geode interchangeable. So literally, you don't have to change any of your application code. And essentially, we've accomplished that. So if you were using something like Redis, you would have probably, and I don't have this on my class path, so it's going to probably turn up red, but enable Redis HTTP session, right? So you've already got, you probably already have, if you're using like Redis as your provider, and now you need a more, robust solution, something like GemFire Geode, so that you can take advantage of more of the system of record use cases type of thing, streaming functions that I've talked about, then to switch that is as simple as basically just changing that annotation to this and you're done. And of course, you probably had some additional configuration to set up your connection factory for Redis. You would no longer need that. And if you're using Spring Data GemFire's annotations, you can easily create a client cache application with a pool next to a server, or a locator if you prefer, just by taking advantage of the annotation config that's in Spring Data GemFire K. So, but in Spring Session, really the only thing you need to do is you just need to change that one annotation, and you're done.
Simple enough. That's great. So before we take the next question, just another quick announcement. Please do remember to evaluate the session and give us feedback. And that's on your panel, on your screen. The feedback we get goes into us selecting topics in future webinars. It's very useful for us to have, so please do attend to that. Okay, next question. What benefits provide over servlet container session management?
Also a really great question. So if you read, that's why I kind of posted this link here for Apache Tomcat's cluster by comparison. If you read into the documentation, there's a bunch of Tomcat-specific things that you need to do in terms of the configuration. You probably do have a choice of providers, though they actually reference, there's, I think in the documentation I saw something about there's a TCP Apache Commons client or Apache Commons library that they're using for doing the clustering between different Tomcat instances. But it's very Tomcat specific. So the advantage of Spring Session is that it's, servlet container neutral. So I can use this again with Tomcat or Jetty or Undertow. It doesn't matter. Whatever Spring Boot supports, Spring Session will work with that. And as I mentioned, actually not only replaces your HTTP session, but can actually work with WebSockets and the web client for reactive sessions as well, which is obviously very powerful in and of itself, and one of the reasons why Spring Session is neutral in that particular case, because not all servlet containers are equal, right? Some of them have the ability to support web reactive sessions, a reactive programming paradigm, and others do not. So that's probably one of the primary benefits of using Spring Session, is that you are not tied to your container.
Cool. So I just noticed that we have a poll question, and the poll question is intended to request information from you on which topics you're interested in. So please do respond to that. Okay, let's move on to our next question. What is the easiest way to get started?
Awesome question as well. Let's back up a few slides. Spring Boot is your easiest way to get started, and to start with Spring Boot, you can just go to start.spring.io, and that will actually get you started creating a project with Spring Session if you would like. I think Spring Session is in there. I haven't actually used this in a while, so I'm not exactly sure what it's probably like a session. There we go. So you can start adding actual capabilities, and of course you can add your provider like Spring Data, GemFire, and so on, or Geode. And I'm forgetting my dependency names here. Actually, it's part of the starter. So whatever the starter support, you go to spring.io, and it'll generate a Spring Boot POM that uses Spring Boot for you. and you're up and running. You're off to the races.
Cool. Is it possible to convert Apache Shiro session to Spring Session way?
Apache Shiro. That's a good question. I don't know the answer to that off the top of my head. Out of the box, I don't believe so. You might have to write some type of adapter to do that. So you'd be using Spring Shiro, obviously, for security, and Spring Session actually has integration with Spring Security proper. So probably why there's no direct way of actually replacing the Shiro session with a Apache, with the Spring Session. So yeah, you'd probably need an adapter for that. But if you're using something like Spring Security, I know that there is good integration with Spring Security, so then you probably wouldn't have as much work involved in making that switch.
Okay. So here's one about comparing Spring Session with HTTP Session. All of these functionality can be handled by HTTP Session. What is the use case for Spring Session where it is a clear advantage over simple HTTP Session?
So from an application perspective, there really isn't much of a difference, right? Like we already said that we encourage users to be using the JavaX servlet type, like HTTP Session, in your applications directly. That actually allows you to be largely agnostic of not only the providers under the hood, but also Spring Session in particular, if you ever were to, say, replace Spring Session. Hopefully not, but that would be the case. However, the power that Spring Session gives you is that it allows you to integrate different providers, whether that be Redis, Apache Geode, GemFire, Hazelcast, whatever the supported providers are. So now you have the power of those particular stores at your fingertips. And as I already showed in this particular session, you have the ability to run queries, do indexing, to perform distributed compute using functions, take advantage of streaming. So as your use case continues to grow beyond just caching, you can start taking advantage of your underlying provider for other points in your application. So in my last talk, we talked about actual caching in the application services tier or your data access tier, right? Using either something like Hibernate's L2 cache or more specifically Spring's cache abstraction. So now you can start tying the same underlying provider into other layers of your application. So that's the advantage that Spring Session gives you. It gives you the ability to leverage different providers, but also use that provider across your entire application architecture for different use cases.
Cool. There are a couple of questions here about scaling and HA for the cache server. Could you please elaborate on how we scale the cache server?
So in Apache Geode and Pivotal GemFire land, actually I've already stopped my server, but let's just give a quick little demo because it's actually quite easy to do. So start him back up. And this is where Pivotal Cloud Foundry is actually really highly valuable. Oops. Actually, I already have my server running in my other ID. Let me stop that one because I want to actually use this one. Sorry, just 1 second. There we go. Now, back here and start this guy up. So I ran into a port bind exception there. Okay. So now, let's go back to GFish. This server started up. And I started it with Spring. Of course, I could have done that with GFish as well. Connect. All right, list members. So to scale up my cluster, there is no auto scaling out of the box with Pivotal GemFire or Apache Geode. It's all, usually it's, you know, our customers would have their own script, their own infrastructure for managing that sort of thing. But if you were just doing it manually, you could just say start server minus name, Geode server, whatever, minus. Disable. I got to disable the default port because my servers are using the default port. Maybe I want to turn up logging level equal config and what have you. So right now I just have my Spring Boot configured GemFire server, and you'll see that actually some stuff happened here in my IDE window. Actually, it showed that another member was joining. and it received a new membership view. So now if I list members, I've got 2 servers. And I can just sit here and do that all day long and add members. And I can also bring those members offline. And this is a shared nothing architecture, which means that while the servers will reconcile differences, if a member goes down or a member gets added, it'll bring it up with a similar configuration, what have you. It's shared nothing, so it doesn't depend on anything. And if you are actually overflowing and persisting your data to disk, then you won't lose data, as well as if you have redundancy set. So when you create a region, you can specify how many copies of that region will actually exist. And if you're using something like a partition region, that region gets divvied up into buckets. So by default, the bucket count is 113, and that gets distributed across all the nodes in the cluster. And then if you have HA enabled, like redundancy on your partition region, each bucket gets duplicated and replicated across the server. So as many servers as I have is however many, and if all those servers are actually hosting the same region, then that'll be how many servers are actually managing your data. And this is how I would scale this up. However, to make it easier, obviously, Pivotal Cloud Foundry makes it simpler by auto-scaling for you based on demand, and you can define all kinds of other criteria for scaling up your cluster, so you don't have to sit here and do this manually. You can define your initial cluster size, and then you can define your rules around how you want to handle your load and scale up and scale back down and so on. Because you're probably going to be running, either on your own data centers or on public cloud infrastructure, and obviously you need to take into account the cost of running compute and using storage and network on public cloud infrastructure like AWS or Google GCP. So hopefully that answers that question.
Yeah, that's great. Any other questions? I have some results from our poll on which topics you're interested in. And it looks like 41% of you are interested in accelerated development, 33 on serverless, and 25 on secure modern infrastructure. So we'll definitely take that feedback with us in planning out our future agenda for webinars. Again, please look at attachment and links, and also look up John Blum. He's going to be presenting at our Spring One Platform Conference coming up in late September. This is our annual conference that has a lot of different tracks and sessions associated. We put a lot of energy into this conference, and John Blum is a regular. I'm sure he'll be there this time presenting topics of interest along the lines of Spring Data. So please do look into that as well. With that, I think we are done in terms of the webinar today. I hope to see you soon again at one of our future upcoming webinars with John Blum. Thank you, John.
Thank you, Jax. Thank you, everybody.